Okay, so first thing we want to do is test the amp. I'm just sort of going through the volume ranges to see what's sort of going on, to see if it matches the customer's complaint. Okay, so I think that tells us quite a bit right there, right? Okay, so the first thing you're going to want to do, probably while the amp is still in the chassis, so that you can have the speaker and everything already hooked up, is just go through your tubes, right? When we were testing it out there, we noticed that the problem got worse when you turned the reverb up, right? And as the volume came up, it was a problem. So probably the place to start would be with your reverb driver tube on these Fender amps. It's a 12AT7 right here. It'll be the third one. Because remember, we always go from the farthest away from the power tubes on these amps. So that'll be V1, V2, 3, 4, 5, 6. And then your power tubes, and on this one a rectifier tube. So might want to start there. Swap out that AT7 with one that you know that works. And only do these one at a time. Then if the problem's still there, put the old one back in, try a 12AX7 here, the return stage. See if that makes a difference. Because it's possible that even though it got worse with the reverb, it could still be in another section. So you just go through systematically, swap out these preamp tubes. It's quick, easy to do, only takes a few minutes while you've got everything hooked up. The next thing you might want to do, if you're not finding anything there, if you've got a spare set of power tubes, you could always plug those in and just do a rough bias, just to sort of see if that's the issue. If you don't have those, we're sort of going to go on to the next step anyway, and we're going to test some voltages and whatnot. Okay, so the other thing that I get a lot of clients telling me is that they're not sure, if it's a preamp tube or a rectifier tube. And the thing I always tell them is that with rectifier tubes on this amp, it's this one over here. Rectifier tubes, they either work or they don't. They're either converting AC to DC or they're not. So if you've got power to the amp, more than likely rectifier tube is okay. Okay, so we've gone through, we've swapped preamp tubes. Another thing you should always check while it's still in the amp, make sure the speaker cable is okay. Let me grab this one here. So you should always check your speaker cable, because they've just got these clip-on ends here, and I can't tell you how many times I've seen them that one is like unhooked and just sort of hanging against one of the tabs or something like that. So always check these cables, and actually I usually replace these with ones that I make myself for clients a lot of the time, because I mean these cables are just cheap. And you'll notice a big sound improvement if you do replace these, but make sure you do check that, because there's been a few times I've had just simple speaker cable problems, and people thought that it was a tube issue or something like that. Okay, so remember, what we're trying to do here is we're just trying to divide this down into smaller and smaller sections to sort of figure out where our problem is, right? And that's the whole thing with this. You're taking a problem that you've got with the amp, and what you're trying to do is isolate it down from the big picture into smaller and smaller chunks, so you can sort of figure out where the problem is, and that'll allow you to sort of focus in on, because I mean, like any of these components in here, they can look absolutely fine, especially like some of these capacitors and stuff. Visually they can pass the test, but you wouldn't really know if they're out of spec, right? They can be failing and you not even be able to see it. So it's kind of a waste of time to go through and be individually testing these. I'm going to show you a couple different ways that you can test them in circuit and whatnot, but you can end up wasting a lot of time. And if you don't have to take the circuit board out, this main board here, you're better off not even touching it, because it takes a lot of time to get this thing out and wiggle things around, and sometimes you even have to desolder some of these wires and stuff in order to get them out. So that's sort of a last ditch resort. Okay, so usually the first thing I'll do in here is just do a really quick visual inspection, just to see if there's any loose components, loose wires, if there's anything burned up, or anything that looks broken, cracked, whatever. So usually another thing that I'll do after I finish my visual inspection, and of course I've already done all this on this amp, usually with the amp powered up, I'll just take a quick bias reading. I'll sort of figure out where we're at output-wise, because funny things can happen. These amps, you don't know how they've been treated. Usually from the factory, they're set a little bit cold. So here's your bias potentiometer right here, and you see sort of where that's tied into the board there. I'll actually post a link, and I might even do a video myself on checking the bias. I like to actually measure the voltages at the plates and calculate it out myself. It gives you a much more accurate reading. I know some guys, they like to put like a 1 ohm resistor in off pin 8 and do it that way, because then, you know, millivolts translates to milliamps pretty much directly. But it'll always be a little bit off, and there's actually been a couple amps I've worked on that had those test points in there for bias. I've checked it on that, the bias has seemed okay, but then, you know, I'd go and double check it for my own curiosity, you know, measuring the plate voltages and stuff like that, and the voltage drop, and calculate it out, and it would be totally wildly different. I'd be getting voltage drops that were, you know, way out of spec, and sometimes that can help you hunt down a problem too. So even though it takes a little bit more time, it's a more accurate way to go about it. And it can sort of save you some time in certain circumstances, because you'll find things, it'll help you isolate, I guess, things that are sort of out of spec. Make sure you check these ribbon cables too, with the amp plugged into a speaker, because you can see there's one here, and there's 2 more over here. Those things are awful. They, I've more times than not, I've seen them go bad, and in amps that develop problems, I've actually seen them burn up, be nothing but carbon left in there. So make sure you check those. Okay, so now that we've done our visual inspection, everything looks pretty much okay. One thing I did notice on my visual inspection here, actually on the output jack, the part that goes to the sleeve, the wire lifted up out of part of the solder joint in there. The rest of the solder joint looks good, and it looks like it's firmly connected, so I'm going to touch that up before we close this amp up, of course. But that's, you know, that's another thing with the visual inspection. When you see stuff like that, it sort of shows you that, you know, a solder joint can look good, but the wire's not actually bonded into that joint. So you want to make sure you go through and do that. Okay, so you're looking down across the amp now, because this is the only way I could get this shot to work. I've got my oscilloscope probe hooked on right on the output well, this one here. You've got your main jack and another external speaker jack, and I just hooked it on the jumper that's right in between those. Or you can just hook it on the little nub there, either way, and make sure that your oscilloscope probe has a good reliable ground right there. And next step is going to be to power this up. So I've run my a speaker cable out here. I built a load box, and this is just a static load with some resistors. I've got it in the 8 ohm setting. So we're going to fire this amp up, and we're going to run a test signal through it. Okay, so with the test signal running through the amp, I usually just run a 1 kilohertz test signal through, and you can see that's what's triggering on the oscilloscope there. And we can see at the output right now it's good. The volume is only at about 2 though, because remember when we had our input, see, this is the thing too, you got to make sure that you have enough input to sort of drive it into the problem stage, right? And this amp, by the way, I checked it. I know in the preview there, I only checked it on the vibrato channel. I checked it on both the normal channel and the vibrato when I initially plugged in to it with the guitar, and you could hear the problem no matter which channel it was in. So that right there should be an indication to us that it's probably not in one of those channels. Okay, so let's give it a little bit more volume here and see what happens. Okay, I'm going to dial that scope down a little bit. Okay, so here we go. Oh, getting a phone call. Okay, so here we are. Busy day today. Phone calls, interruptions, and everything else. Okay, so we're going to start turning the volume up on the amp to drive the input a little bit, or yeah, drive the volume through a little bit more. Alright, and right there. So I usually like to test it this way just by turning the volume up, and we're up to, as you start getting up into 4, or just past 4 on the volume, that's when you start to have the problem here. And that's what we observed when playing through it too. The other thing that you can do is turn the volume down and up the output of your signal generator and see if it does it there. You don't want to go too hot though, because I mean at some point you're going to get more signal than what any instrument would generate anyway. So we see that jagged, jumpy stuff happening there. So that should be an indication that there's a problem. And remember, so we'll get it sort of here on the edge. Remember, the other thing that happened was when we turned the reverb on, there was that really nasty sort of ringing, right? So let's try bringing a bit of that in. And we see everything just goes nuts, right? So that gives us a little bit of an indication as to where to go to next, okay? Okay, so the next step after we check that, and we see at the output that we're getting that that distortion, the next next thing we want to do, because it gets worse with the reverb, right? Depending on which type of amp it is and the problem, just from doing this a lot, I'll either start working from the power section backwards and see where the problem stops, or I'll go from the input of the amp and see where the problem starts. Okay, so I'll try and remember where I was at here. I just had a large series of interruptions. Okay, so we're assuming that I've gone along and done the testing with the oscilloscope, assuming you have one, and we've sort of traced it down to the problem starting around the reverb circuit. So I'd do an even closer inspection of all the components. I'd maybe test some of the resistor. Well, make sure that there's no cracks in anything. Make sure that your electrolytics look good. So the tube bias is okay. They're obviously lighting up, so we've got power on the filaments. Assuming all that stuff just sort of looks okay, instead of pulling the board out again, the first thing that I'd do is check some voltages, because that's going to tell you a lot. And this is a step you'd skip to if you didn't have an oscilloscope and you were just sort of going through section by section. So I'm going to take... there's power on the amp right now, so you've got to be careful. But so I'm going to take this probe and I'm going to start testing voltages on the tube and at a couple different places on the board. So we'll have to refer to the schematic here to sort of get an idea of what we're looking for and where we're going to go. Okay, so remember as you're doing this to be really careful not to short anything out as you're going along. First thing that we want to do, and I'll explain this when we looked at the schematic, but or maybe I've already explained it depending on what order I put these clips in for checking this. But so the thing that we're going to do here is we're going to check just our voltages at pin 1 on the tube. So this is going to be our 12 AT7, okay? So I'm very carefully going to, and watch the voltage reading. So I've set to DC here on my meter, and I've got the black lead hooked to ground here on the chassis. So I'm going to very carefully come in here and touch that to pin 1. We see we're getting a reading of 360 volts, or thereabouts. 363. Way too high. Way too high for 12 AT7 or even a 12 AX7. While we're right here, why don't we check the voltage on this one here. So there we're getting 176 on our return tube. Okay, and if you go back here to, I know that they're performing different different functions, but like if we go back over here to V2, we're getting 169. And our other 12X7 over here, you know, we're getting what was it? About 175 on both halves of it. But on that 12AT7, we've got a really high voltage there. So what we want to do, and I'll explain why that's a really high reading here in a minute, but that we want to go through and we want to check what's supplying that. The other thing I usually check too while I'm in here is the voltages just for a transformer, just to make sure that you don't have a shorted out transformer or something like that, because that can do weird things as well. Okay, so the next thing that we're going to want to do is check voltages, both of the bias of the tube to make sure we've got the right drop happening there, but also we'll want to check the components that are coming from the power supply into that tube, because if that's most likely what it is with a high voltage like that. It's most likely the voltage coming into the tube is wrong, because that's really high. That's, you know, over double what it should be. So I'm going to go quickly print off a schematic here, and we're going to take a look at it so that we can see which part we should be checking next. So if we look here at 12AT7, first thing I like to do with my preamp tubes is check my plate voltages, because that can give us a clue. You'll notice here there's a 60 volt AC written on this. I usually check the DC voltage on those plates, even though, because I sort of know what range they should be in, usually around 160, 170. DC is a good range for most preamp tubes. So you'll notice when we check that, there seems to be a really high voltage here, and we check it all the way back through that reverb transformer, and it's coming in that input Z there. We're getting a really high voltage there. I would also go and check the bias resistor and that capacitor, just to make sure that they're in check, and everything was fine there. So from there we're going to move on. So we already did this one here. We've got 364, and those ones are bridged, so those are the same. This one here, V4, we've got 170 there. I'm not getting a good connection on that one because I can't see. Yeah, 175 there. Oh, look at this one. 362. 315. So that's the one after. Well, if you look at the schematic, that's for the vibrato driver. So then you want to go back and you want to check. It says in the schematic these are all 100K, so you check them there, and you check the opposite side of them too. And we can sort of see that you know, we're not knocking down much across those, right? And since we're getting that much coming into those resistors, you see all these ones here are fine. We would want to see what they have in common, right? So just to summarize quickly, the 12AT7, that's our V3 tube, I believe, that had a plate voltage that was pretty high. V4 was fine. And now we're going to move on. I want to check the other ones just because we want other things to sort of help us confirm our problem. We want to know whether maybe we've got a bad reverb transformer, or if it's another component in that section. But but I went over here and I quickly measured V5, and the plate voltages on V5 were extremely high as well. They were just as high as they were on that 12AT7. So if you look, those are all have that Z connection point in the power supply. They all have that in common. It's very unlikely that multiple components would fail at the same time. Since they all have that Z input in common, it's fairly likely that it's our power supply. So when we look at our connection point Z here in the power supply, we'd want to go through and we're going to test each of these caps. Now, I have an ESR meter. I find that's the quickest and easiest way, at least to start out with, to test caps. If not, you just desolder them one leg, and you can go through, if you've got a multimeter that has a capacitor tester on it, that's going to give you the values. You also want to test them to see if there's any continuity through them. There shouldn't be. So we're going to go through one at a time. And we're also going to check these resistors in here, do both a visual inspection for any sort of cracks or heat damage, and also check the values that are on them. So these are all our power supply caps right here, and I'm going to start testing them. One disclaimer, make sure these filter caps are drained, that you've had the amp unplugged for a while, or that you have a resistor, a bleed resistor you can put on there just to drain off any excess voltage, because it will stick in those filter caps and it can really burn you if you're not careful. Okay, so what I'm going to be using to test these is an ESR meter. These are great because I can test the caps in circuit and I don't even have to take them out. And this is just a really quick way to do it. If you don't have this, having the multimeter is perfectly fine. You know, you just lift one leg and you go from there. Okay, so try to get this all in the shot here. Okay, so I just go through one right after the other. Now in our schematic there, we sort of theorized that it would probably be C33 that would be our problem, because that was the one that's common to that connection point, and that would be this cap right here. Okay, so just for the purposes of doing this, I'm just going to go through one at a time so that you can sort of see. So that one there, 2.1, that one's good. That one there, 1.9, it's in an okay range. C33 here. Oh, look at that. We get nothing. I get that one clipped on there properly. That one's a 1.0. And then our little guy here on the end, 0.08. So that one's fine. So, C33. Nothing. So that capacitor, even though visually, when you get down and inspect it, looks perfectly fine, that's the one there, that no juice. So next step would be to pull that board up. And even though I'm not going to show it here, I already went through and I tested those resistors to make sure that they were okay. When you have a cap like this that's not performing properly, sometimes it can stress some of those. So if there's any heat damage or anything, you just want to replace those just proactively, because they'd fail anyway prematurely eventually if they've had too much of a load put on them. And you can check your schematic to see which ones are in line with that C33, and you could replace those.